Hey class, this video is on distance of lines. Just gonna go through this video pretty fast. It's for the most part very similar to our last topic, which is Pythagorean theorem. So the first blank, it says, we can calculate the length of lines by using the Pythagorean theorem. So that's a squared plus b squared equal to c squared. Certain things I don't want you to confuse this with is slope. That's where you're finding of a line rise over run. Or y equals mx plus b, slope intercept form. That's where you find the y-intercept and then also the slope, and then write it into an equation. That's not what we're doing. What we're finding is the length of the line. So how are we going to do that? We're going to create and then this right over here is a right triangle where the line that we have over here is the hypotenuse. Okay, so we have two examples. Now before I get to these examples, let me just show you that. Let's say over here, you don't have to draw this. And this line, pretty easy to find the length. If I just count the spaces here, or the boxes, it's just a length of 4, right? So that's pretty easy. Here, I don't count like 1, 2, 3, like, no. Like it's diagonals, it's hard to count how many units there are. So we're gonna create a right triangle. I'm gonna create it like this. Draw a line vertically and horizontally. And you could draw it any other way. If you wanted to draw it like this, you could also draw it like that. I just have it like this. So let's find the legs of this right triangle. Right, the legs are always the sides right next to the right angle. This over here is 4, and the one that goes upright is, if you count it out, it's 7. Leaving this of a right triangle is our hypotenuse. It's c. So if I plug this in, we're gonna have, instead of a squared, we're gonna have 4 squared. 7 and for b, so 7 squared equal to c squared. And just simplifying, 4 squared is 16, 7 squared is 49, equal to c squared. And if we add up 16 and 49, that's 50. Okay, so I think it's 65 equal to c squared. Now when we solve, we have to find what c is. We don't have c isolated here. So what I have to do is I have to write a square root to both sides. And you can try to do a factor tree of 65. It actually won't work out. Two factors, or factors that can go into it, are 5 and 13. Neither of those can be broken up or create pairs. So our final answer is c equal to radical 65 units. Now for this, so this is simplified. If we were to estimate, 65 is very close to 64. Square root of 64 is 8. Since this is a little bit above that, if I were to estimate, this would probably be like 8.1, something very close to it, 8.1 units. But we're just going to leave it as square root of 65. Next one, and our last one. Here, I'm going to draw a vertical line from here, and looks like it's going to go down here, like that. And I just figure out the distance again on the legs. So it looks like we're gonna have 5 off to the left and then 12 down here. Right, this is the right angle. So the hypotenuse, this length of this line, we don't know what it is. We're gonna try to find that using the Pythagorean theorem. So instead of a squared, we're gonna have 5 squared. B squared, we're gonna have 12 squared. And c will remain. 5 squared is, so 5 times 5 is 25. 12 squared, 12 times 12 is 144. And then we leave the right hand side. We can add the left-hand side, giving us 169 equal to c squared. And same exact thing that we encountered in the first problem is we're going to have to apply the square roots to both sides. And here we're going to have squares undo square roots, so we're just left with c. And the square roots of 169 is a perfect square. The answer to that is just 13. Right, 13 times 13, if you want to work it out, is 169. So our final answer here is just 13. I'm gonna put UN for units. All right, guys, that's the video on distance of lines. Let me know if you guys got questions. Bye.